Hello, welcome to this video tutorial. In this lesson, we will look at interfaces in Golang. We will look at what they are, why do we need them. So grab your code editor, hit that like button, and let's get started. Now let's start with the basics. An interface in Go is a type that defines a set of method signatures, but doesn't implement them. So it's like a contract that says, for an example, any type that wants to be considered a part of this interface must have these methods. So here is a simple analogy. Imagine you have a USB port on your computer. It doesn't matter if you plug in a keyboard or a mouse or a flash drive. As long as the device follows the USB standard, it will work. Exactly. Similarly in Go, if a type implements all the methods of an interface, it satisfies the interface automatically. Let's look at an example in our editor. Now we have our main.go file, we have our package main. Now let's declare our type, our interface, and call it speaker. Good. And we say that it's an interface, so we add it over here. Interface. Good, exactly. And we will give it a method of speak. Good. So we will say that this speaker interface speak. So this is the speak method that will give our interface. Now let's come ahead and declare a struct, and let's say and call it person. Good. And we say that that one is a struct, and for the person we will say that it has a name. Exactly. Good. It has a name, and the name is a string. All right. Now let's implement the speak method for the person struct over here. So we are going to implement the speak method for the speaker interface for the person struct. So this is how we will do it. We create a function and we will declare the speak method over here, and we will bind it to the person struct that we have over here. Right, good. So you will bind it to the person struct over here, and you go ahead and print the name. Exactly. Good. Now this is it. So we have our speak method here. So speak method here is from the speaker interface over here, and we have bind it to the person struct. So we have actually implemented the speak method for the person as we see it over here. Good. Now we will print the name of the person, and let's add and say that the name of the person says hello. Hello Go. Let's add that. Okay, good. So let's begin our main function over here. Good. And in our main function, we will declare a variable p, and we will say that it is an instance of the person struct that we have already declared. Okay, and we will give it a name. Let's say John. Okay, let's say John. All right, good. Now in our main function, we will declare a variable of the type speaker, and we will assign a person to it. Do you get that? Good. Now let's declare a variable, let's say var, and say s, and we will say that that variable is actually a type speaker. So it is actually a type of the speaker. Instead of it to have a type like an int or a string, it is the type is the speaker. Are we seeing it over here? And we will say that that is equal to the p that we have declared over there. and you will give it the method speak like as we have it over here. Good. Exactly. Good. Now, in this example, we see that we define a speaker interface over here. We define a speaker interface over here, and with the speak method as we see it inside over here. Yeah. And we also declared and defined a person struct over here. And we saw that the person struct that we have created over here actually implements the speak method over here. So the speak method is from the speaker interface, and the person struct over here is binded to it. It is actually implementing it. Good. And because the person has the speak method, the person struct over here has the speak method over here, it automatically satisfies the speaker interface. It's as simple as that. You see that? So Go doesn't require explicit declaration like other languages. As long as a type has the method required by an interface, we see that it is valid. Now let's look at why use interfaces. Now you might be wondering why use interfaces when we can just call the method directly. Now for flexibility, so interfaces actually allows us to write code that works with multiple types, and our code also depend on behavior, not concrete implementation. And we can also actually easily replace implementation when writing tests. Now let's look at an example using an interface for multiple structs. So let's clear this example over here, and let's say we have our interface called animal. Okay, then we say that it's an interface. All right, good. And that interface, you will say that it has a method called make sound. Make sound. Okay, it has the method called make sound method. Now let's define a struct called dog. Okay, good. And we will give our dog a name. Okay, and you say that it's a string. Okay, and we also create another struct called a cat. Okay, and you also give it a name of string. Okay, now we will implement our dog struct to actually implement the make sound method of the interface. So over here, we will say that we will bind the dog struct to the make sound method of the animal interface. So let's say the dog, so give a D representation of it and bring in our dog struct over here, and we will implement the make sound method over here, and we will say that we will print that that particular dog will say woo. Okay, so good. And we will say that let's bring in a format package over here, and you okay, so let's say that dog. So okay, so our package is being imported, and we shouldn't see this error. Okay, And now similarly we will do that also for the cat struct to implement the make sound method of the animal interface as well. Good. And we will give a C representation for the cat struct, and we will say we also print that the name of the cat says meow. Okay, good. As we have it over here. Exactly. Now we will come enter into our main function, and we will now say give create an instance of the dog and the cat. We will create an instance for the dog and the cat as we see it over here, and we will give the dog a name called Buddy as we see it over here. Good. And now we will use the animal interface over here. So you say animal, you say that the animals will create a variable for and call it animals, and you say that it's actually going to use the animal interface over here slice, and we say that the animal dog and the cat. So we create our animals over here, and we actually make implement the animal interface. We use it and create it as a slice. So the dog and the cat will come inside here as a slice. So let's use a for loop to range over them and um, print out the make sound method for them. Good. Now with our for loop, we will say that the animal, and we will say that we will range it over the animals that we have created, and we will say that each animal makes sound. Good. Alright. Okay, so let's run our program to see so far. Let's bring in our terminal. Okay, so go run dot go and look at it. Now we see it over here. The body, which is the dog, says wolf, and the whiskers over here meow. Exactly. Now here, both the dog and the cat implement the make sound over here. The cat implements it, and the dog also implements the make sound method. You see, so you can actually have it like that. If it were not supposed to be a method in the struct and you create a function with the same name, you will get an error. But because it's actually a method from the animal interface, you see it works. So the cat implements it, the dog also implements it, making them valid animal types. And instead of writing separate functions for each animal, we use an interface to handle them all in a flexible way. Good. That is it for this lesson. Please like this video, subscribe, and comment in the comment section below. In our next lesson, we will look at a more practical project that implements all these principles. Thank you. See you in the next video.